Still more practice with rational equations. In this example, we have x squared minus 1 over x plus 2 equal to 3 over x plus 2. All right, so the first thing that I notice is that the denominators are the same, right? So the LCD is x plus 2. And if we, I should also say x can't be negative 2, right? That's would give us trouble in the denominator there. Okay, so the first thing that we're going to do is multiply both sides of this by the LCD of x plus 2. Okay, now this is an example where you've got a single fraction equal to a single fraction, and you could cross multiply, but you will end up with something much nastier than if you just multiply by the LCD. So with the LCD here, we've got x squared minus 1 equal to 3, right, when the denominator cancels out. And so just to before I get any further with this, that comment that I just made, like don't go cross multiplying here. If you multiply x squared minus 1 times x plus 2, you're going to get a cubic, right? So which potentially is not factorable, and you're going to have some trouble there. So that's problematic. And so generally speaking, just stick to multiplying both sides by the LCD. All right, so in this instance, we're going to have it's quadratic. It doesn't have a middle term, so you can do it. You can either add 1 to both sides here and then take the square root of both sides, or you can subtract 3 from both sides and then factor it. I'm going to do it. So I have x squared minus 4 equal to 0, and that factors, right? It's a difference of squares, so I have x plus 2 times x minus 2 equal to 0, and x plus 2 equals 0, or x minus 2 equals 0. So here, if I subtract 2 from both sides, I'll have x equal to negative 2. And with x minus 2 equals 0, if I add 2 to both sides, I'll have x is equal to 2. Okay, and do both of those work? Yeah. Actually, I'll also say from right here, if we simply add 1 to both sides, then you have x squared equal to 4. Take the square root of both sides. You have to remember that x can be positive or negative, right? When you square it, it's always positive. So x is equivalent to plus or minus 2 here. You can do it this way. You can do it the way that I did in setting it equal to 0 and factoring. Either way is okay. Now, in the original domain restriction, we said that x can't be negative 2, right? So careful with that. We know that x can't be negative 2 just by the domain restriction. I could check it. You could check it if you want. Mentally, if you put negative 2 into the original equation, you're going to have 0 in the denominator, right? Even though it's on both sides, it can't be a solution. So my other question would be, okay, let's just check the one that I know works or should work, right, which is x equal positive 2. So if I put a positive 2 squared minus 1 over 2 plus 2, is that equivalent to 3 over 2 plus 2? Okay, so that's the question. 4 minus 1 is 3, and 2 plus 2 is 4, so we have 3/4 equal to 3/4. Yes, indeed, it does work. Okay, so the solution set is 2, right? Okay. And just to piggyback on my earlier comment about the fact that negative 2 doesn't work, I know because of the domain restriction that we can't include that in the solution. But let's say you failed to notice that. You could try to stick it in there. Negative 2 squared minus 1 over negative 2 plus 2. Right, already I've got trouble in that denominator, right? So 3 over negative 2 plus 2. So that would give you, let's see, 4 minus 1 is 3. 3 over 0 equal to 3 over 0. Now, occasionally, I will have people tell me, well, 3 over 0 equals 3 over 0, right? It's the same thing. But 3 over 0 is undefined. So because we can't define it, those two things can't be set equal to one another. So it's not part of the solution. One last example. We have y plus 3 over y plus 2 minus y over y squared minus 4 equal to y over y minus 2. All right, so the first thing I want to do is make sure everything is fully factored in the denominator. So I have y plus 3 over y plus 2 minus y over y squared minus 4 is the difference of squares, right? So it's y plus 2 times y minus 2 equal to y over y minus 2. All right, so let's talk LCD. What's the LCD here? The factors are y plus 2 and y minus 2, right? They're both included in that second fraction on the left, but they're only included once in any one of the given denominators, right? So I would also say, okay, y can't be plus or minus 2, right? That would make either one of those factors 0, right? So if we get plus or minus 2, we're going to have some trouble. Okay, so to solve this now, I'm going to multiply both sides by y plus 2 times y minus 2. So when I do this, so I'm going to write a step now that's maybe not completely necessary for all of you, but if it helps you to see it, do write it. So like on the left-hand side, we're multiplying that entire LCD to both of the terms that we see there, right? So we're going to have y plus 2 times y minus 2 times y plus 3 all over y plus 2 minus y times y plus 2 times y minus 2 all over y plus 2 times y minus 2, right? Okay. And then over here on the right, we've just got one term, and I know that the y minus 2 is going to cancel out, so I'm going to be left with y times y plus 2 there. Okay. All right, so take a look at what happens here. The y plus 2's cancel in the first term, and in the second term, the whole LCD leaves, right? Y plus 2 times y minus 2. Okay, so what are we left with? We're left with y minus 2 times y plus 3 minus y equal to y squared plus 2y, right? I'm just going to go ahead and distribute the y through. And then on the left here, I'm going to FOIL this, right? Y minus 2 times y plus 3, we've got y squared. The middle term is going to be, let's see, 3y minus 2y is just y. Negative 2 times 3 is minus 6. Minus y equal to y squared plus 2y. Okay, so on the left-hand side, y minus y goes away, right? And I'm going to go ahead and subtract y squared from both sides, right? So y squared minus 6 equal to y squared minus y squared plus 2y. So now I have negative 6 equal to 2y, and I'm going to divide both sides by 2. So I have negative 3 equal to y. Okay, now the domain restriction said that y couldn't be plus or minus 2. I got negative 3 as an answer, so that should be okay. Now let's check it and just make sure that it actually works. If it doesn't disobey the domain restriction, it probably does. So negative 3 plus 3 divided by negative 3 plus 2 minus negative 3 over negative 3 quantity squared minus 4 equal to negative 3 over negative 3 minus 2. Okay, is that a true statement? So the first fraction, the numerator is going to be 0, right? So 0 over anything is still 0, yes? Okay, and then we're going to subtract Negative 3 over 9 minus 4 is 5. And then over here we're going to have negative 3 over negative 5. So on the left, 0 minus negative 3/5 is 3/5. And then negative 3 divided by negative 5 is positive 3/5. So it does work. A little bit of fraction work there. Okay, so the solution set is negative 3. Very good.